You stand. It's already rolling. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Slightly new topic. Same topic, different direction. Topic for today is reconstructing a conic equation. I'm going to do a quick review first. There are 4 types of conic. There are 4 types of conic. What's the first one we ever studied?
Parabolas.
That was actually the third one. But,
Circle.
yeah, circle. Who can give me the general formula for a circle? Go.
Y minus h squared.
Kind of, sort of. Not y, but
X
x minus
h
h parentheses squared. Good.
plus
Plus. Good.
y minus k squared.
Equals what?
1. No, 0.
Normally,
Oh, radius squared.
radius squared. X minus h parentheses squared plus y minus k parentheses squared equals r squared. That's the standard form of a circle, where the center is h comma k, and the radius is r. Make sense? Those are the only 2 pieces you have to find for a circle too when you analyze it, the center and the radius. Second thing, what was the second shape we covered? 31 is parabola, by the way. Go. Ellipse, good. You have the formula for it?
X minus h parentheses squared
Good.
over hr squared.
Yeah, what does that stand for?
Horizontal radius
Horizontal radius squared, okay.
plus
Mhm.
y minus k parentheses squared
Okay,
over vertical radius squared
good,
equals 1.
correct. On the top, it's identical to a circle formula. On the bottom, you're divided by, you notice all the horizontal stuff is together. H is horizontal, X is horizontal radius is obviously horizontal. They all hang together. Same thing with the vertical stuff. With an ellipse, wow, I can spell. Ellipse. Ellipse. The center is still h comma k. HR and VR are the horizontal radius and vertical radius. I'm just going to do ditto marks there. Does that make sense? There are how many analysis parts for a circle? Okay.
2.
2, correct. How many for an ellipse?
I don't remember.
Okay. Will, how many analysis parts for an ellipse? 12, correct. Eventually, we're going to have 3 and 13. But right now, it's 2 and 12. We have not covered the last one yet. Third shape. That's what I gave it away. Parabola. A parabola, normally we had 1 equation, but now it turns out we have 2. Here's the first one. Y equals a parentheses x minus h squared plus k. Can somebody give me the other version? Sam.
X equals
X equals
a parentheses y minus h.
close. Y minus k, parentheses squared, plus h. Good. The second version, what's different about it? Oscar?
The second version, the parabola is gonna be, the arrows will be facing left to right.
Correct. In other words, it opens, I'll be out of it in just a second, horizontally. In the top one, it opens vertically. How do you tell which is which? Like if I got as a formula, how do you know whether it's opening up, down, left, or right? Carter, what do you think? It's a game we learned before kindergarten even. Follow the leader. Right. The leader, I'm going to do quote unquote follow the leader. And the leader is the non-squared variable. Whichever variable is never squared, that's the leader in the parabola. So if one variable is squared and one's not, that has to be a parabola, as far as we know. Everybody okay so far? And then in this case, the vertex, V, is h comma k in both cases. And then A is the height multiplier. Can somebody tell me how many analysis parts a parabola has? Jeff? It has 6. And eventually there will be 7. There used to be 5, but we added axis of symmetry to the list. Everybody right so far? We just covered yesterday hyperbola. Again, good news and bad news on this. The bad news is you got 2 more formulas to memorize. The good news is they're almost identical to previous 2. Like what? Mary Claire, what does the hyperbola formula look a lot like? Kind of, sort of. It's almost a clone of one of the previous ones, with just one tiny change. An ellipse, correct. A hyperbola is an ellipse turned inside out. What's the only change? In other words, you'd be identical, both of them have horizontal and vertical radii. What's the only thing that's different about formula for hyperbola versus an ellipse? Subtraction. Got it. So clone it, x minus h parentheses squared over hr squared minus y minus k squared over vr squared equals 1. But there is another version, the backwards version. Y minus k squared over vr squared minus x minus h squared over horizontal radius squared equals 1. What's the difference? Sam?
The bottom one is switched around.
Yeah. Does that make a difference? Because in ellipse, it wouldn't.
It changes it from being flip, no, not flip, facing left, right, and facing up, down.
Right. One of these is facing left, right, and one of these is facing up, down. If you remember, a hyperbola looks like this thing. It's with 2 branches that are facing opposite directions. But they might also go up, down. How do you tell which is which? Well, how do you know which of these is going up, down, and which of these is going left, right? There's one tiny thing that gives it away. Like this top one. Would you guess that it's opening left, right, or opening it down?
Left, right.
Okay. Why?
No.
Okay. How do you tell which way a parabola is opening?
Because if it's positive or negative. Like, you mean like the...
True. That's true if it goes up or down. But how can you tell whether it's vertical or horizontal?
If the variables are switched.
Yes. And now, which one would have to be first in order to be going up, down?
The y.
Y. In other words, Y is the leader. Exact same thing here. Whichever variable is physically first, that's the leader. And in this case, follow the leader. I'm going to steal a metaphor from my old high school math teacher, God rest his soul, Mr. Myers. He used to, if you think of these four shapes, like here's, let me just draw them real fast, real cheesy. These two are what I call enclosed. They don't open up. They don't go out anywhere. Parabola opens up, and a hyperbola opens up two directions. Or this way. I didn't draw that very well. It's supposed to be even. If you go outward, this is his metaphor. If you go outward, you need a leader. If we're going out of the building, we need a leader if we're going in a group. If you're going alone, or if you're just going to lunch or something, do it on your own. But if we're doing something official, school official, we need a leader. Somebody's going to lead the way. If we're not going anywhere, you don't need a leader, not necessarily. So if you're trapped in a room, this is what my high school math teacher used to say, how do you tell who's in charge in a closed room? Well, he said, like, which one is most important for an ellipse? How do you tell which one is A? Remember the A, B, and C? Which radius is A in an ellipse? Yeah. The major radius, the one that's biggest. How do you tell which one is A in a hyperbola? Different test. Look at your notes if you have to. A is equal to what? A is not the major radius in an ellipse, it's something else. Go. It's the leader. Whoever the leader is, correct. If you're in an ellipse, you don't need a leader. Well, here's another way. If you don't have a leader, then people tend to be kind of brutish. They say if there's no leader in here, then human nature as it is had a tendency to say, whoever's biggest is going to beat up everybody else, and then everybody else has to do what the big person says. That's what's happening in an ellipse. Everybody's trapped in one little room, and there's no leader, so Biff over here, who's the biggest of the two radii, is going to be in charge of the room. I'll spare you the voice. Maybe later. But over here, if you have a leader, if you're actually going out, you follow that leader. Even if the leader is only like 5'1" or something like 4'3". I forgot how tall Napoleon was, but he was pretty short. But he's still a leader. He's a famous leader. He was a kind of nasty leader, but he was famous. And nobody could deny that he was a good leader. He was a brilliant commander and such. He was not very tall, but he led. So if you're going outward, you follow a leader, whether it's big or not. Down here, A is the leader radius, whether it's big or not. In an ellipse, A is the biggest one. Does that make sense? So in an ellipse, A and B are the big and the small radii. In a hyperbola, A and B are the leader and the follower radius, and it doesn't matter who's biggest. Whoever's the leader, follow them. There is no leader in an enclosed, so you just follow whoever's biggest, which is sad. Questions for everyone? Okay. How many analysis parts does a hyperbola have? Mary? Peek in your notes if you have to, but see if you can remember.
Is it 13?
It's 14. Correct. And eventually we'll cover 15. But for now it's 14. Let's see if we can list them. For a circle, what parts? Please.
Center.
Center and
Radius.
radius, and that's it. first, like, give me three of the things that are easy to find in an ellipse. What's it?
Center,
Definitely center,
the horizontal.
horizontal radius, vertical radius. There are gonna be 12, we've got 3 so far. Take over, Nick.
The major vertices.
True, you gotta find a major something first.
What's A?
Yeah, A,
A, B, and C.
B, and C. And A, what is A again?
Major vertices.
Not the major vertices, but the major
Major radius.
radius, the biggest radius. And then B is the minor radius. And what's C? The small c.
I have no idea.
Okay.
Focal move.
It's the focal move. So we've got 1, 2, 3, 4, 5, 6. 6 more things. Precalculus, take over. What other parts can you find in an ellipse?
The foci,
Yeah, how many?
2,
Yeah, focus 1, focus 2, good. And then 4 more things, which are all related.
major minor vertices.
Yeah, vertex 1, 2, 3, 4. And again, the vertex 1 and 2 are the major ones. And vertex 3 and vertex 4 are the minor ones. Okay, that's how you find it. Can somebody refresh my memory for ellipse? What is the formula for the focal move? Abby.
Radical
Uh,
a squared minus b squared.
Correct. Radical a squared minus b squared. That's how you find the focal move, how far the focus is from the center of an ellipse. Okay. What about parabola? We need 6 parts. Name them. Josh. What do you find first?
The vertex.
Definitely the vertex. Then what?
Find the focus.
You could, there's something you have to find first. And something that's sort of staring at you in the formula itself. One of the letters. Okay. Yeah, height multiplier. So it's A. By the way, A is not the same thing as A in ellipse and hyperbola, because it doesn't have radii. So, okay. What about that? Sam, take over.
Focal move,
Focal move. Keep going.
and then focus,
Focus. How many?
1,
Yeah, there's only one focus in a parabola. Keep going.
the
Directrix.
6,
And then
the axis, symmetry.
axis of symmetry. Those are the 6 things you find in a parabola. While you're at it, can you tell me the formula for the focal move for a parabola?
1/4a.
1/4a. Correct. And that could be positive, it could be negative, depending on whether it's going up or down, or east, or left or right. How about hyperbola? We discovered this yesterday. There are 14 parts. Some parts, there's going to be a lot of overlap with an ellipse, but some of them are missing, and there are some new ones. So, okay. Give me a first few. What's the very first thing you'd find in hyperbola?
Center.
Definitely center. Then what?
Horizontal radius. Vertical.
Good. Horizontal radius, vertical radius. And then 3 more letters that come in rapid succession.
A,
A,
B,
B,
C.
C. Tell me what A stands for.
The leader radius.
The leader radius, not the biggest, except by accident. And what's B?
Follower radius.
Yeah. B is the follower radius. And what's C?
The focal move.
Focal move. Can you tell me what the formula for focal move for a hyperbola is? Megan.
Radical a squared plus b squared.
Yes. If you notice, the only thing separating an ellipse from a hyperbola, they change plus to minus in the main formula. So they change minus to plus in the focal move formula. Bless you. Make sense? So you go 1, 2, 3, 4, 5, 6. We've got 8 more. Blaze, take over. What else can you find in a hyperbola? We just got a focal move, so probably,
Oh, the foci.
how many?
2.
There are 2 foci. Okay, what else? Now, I've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 6 more things. Like what? Question. Sam, how many vertices does a hyperbola have? 2. It has one where the first pseudo-parabola starts and one where the other one starts. So there are 2 vertices, vertex 1, vertex 2. There are 4 more parts, and these are all new. What new shapes showed up in a hyperbola that we've never seen in any of the other conics? Oh, math people, go. Asymptotes. So write these. Little m1, little m2, capital A1, capital A2. What do those m's stand for? Nick.
I do not know.
Okay. Mary.
It's not.
I'll give you a hint from both of it. What was it?
Is it the slope?
Yes. Those are the slopes. It's the slope of the first asymptote, and this is the slope of the second asymptote. I'll ask you for formulas on those in a minute, somebody. But what are A1 and A2? Very clear.
The equations of the asymptote?
Yeah, these are the equations of the asymptotes. This is the asymptote number 1 equation. And it's going to be in point slope form. And this is the asymptote number 2 equation. I'm abbreviating horribly here. But yeah, you have 2 equations of 2 asymptotes that are splitting right through the function. Well, maybe not function, the formula. Let's try one, see what you remember. Oh, that's right. Hang on a second. The people watching at home, there are a couple of formulas that just went off screen. My bad. The left-hand side, you can see the analysis. Let me creep this over. So the very top, I don't know if you can see my finger pointing here. The very top one here is C equals radical A squared minus B squared. That's the focal move for an ellipse. Second one, C equals 1 over 4A, focal move for a parabola. Third, C equals radical A squared plus B squared. Sorry, my finger is wobbling. The focal move for a hyperbola. Back over. All right, let's try this. Suppose I give you the following. As a matter of fact, let's skip a step. I have something for y'all. This is your next homework assignment. 6C-3, hyperbolas. This one actually is hyperbolas, unlike the typo I had last time. I would like to try number 3. You got it, yeah.
Are we gonna have homework for this number?
You'll find out. So look at problem number 3 on the front page, front side of the page. X squared over 25. Actually, I take that back. Let's try number 4. Number 3 is actually a little easier than that. I want to save the easy one for you. Try number 4. Look at, by the way, number 3. Can anybody figure out where the center of that thing is? I don't see any parentheses. It's what? I think I heard it. Go. It's 0, 0. It's basically x minus 0. I heard it. Yeah. X minus 0 parentheses squared and y minus 0 parentheses squared. Whenever you see a plain old x squared or a plain old y squared, it means the center is going to be at 0 comma something or something comma 0. Number 4, let's try this. Y minus 1 squared over 16. Is number 4. And then minus x minus 2 parentheses squared over 9 equals 1. First and foremost, Nate, what shape is this thing? Hyperbola. Why is it not a circle? 2 reasons. Yeah, there's stuff on the bottom, and they're different. If this had been 16, and this had been 16, and this had been plus, it would have been a circle. But they're different radii. There's one other reason which I sort of alluded to. Becca, what's another reason why this is not a circle? They mentioned that these two numbers are different, which is true. There's one other thing that makes this not a circle. The minus sign. It has to be a plus sign to be a circle. Why isn't it a parabola? Katie.
Because both of them are squared.
Yes, both variables are squared. In a parabola, only one variable is squared and one is not. Depends on which. So why isn't it an ellipse? Josh? Looks a lot like an ellipse. There's one thing stopping it. Yes, the ellipse is plus in the middle, not minus. So this has to be a hyperbola. Bless you. So, start me off, Chaley, where's the center of this thing?
2, 1.
Correct. Be careful, you notice the y's came first. Don't be fooled into thinking this is 1 comma 2. The x's part, wow, that wasn't English. The x parts come first. While you're at it, Courtney, what's horizontal radius?
6 or 9.
You're getting closer. That's already squared.
Oh, 3.
Yeah, it's a radical 9, which is 3. And again, all the horizontal stuff is in one clump. Abby, what's the vertical radius?
Radical 16, which is 4.
Yeah, radical 16, which is 4. Everybody okay so far? Megan, take over. Which one is A? The vertical. Tell me why. Yeah, it's not because it's biggest. Well, that's just a coincidence. Because this is the leader. Not because it's biggest, because it's first. Physically first in the problem. So in other words, this would be B. Make sense over? Blaze, what is the formula for the focal move of this thing? For a hyperbola?
Oh, radical a squared minus b squared.
Yeah, you're close.
Or plus b squared.
Yeah, whatever the formula is, you do the opposite. A squared plus b squared. Go ahead and do that for me. So it's radical what?
9 plus 16.
Yeah, in this case, 16 plus 9. What is that going to give you?
25.
25. What is radical 25?
5.
5. The focal move is 5. By the way, that's lucky. Usually the focal move is atrocious. It's like radical 29 or something. So if it comes up a whole number, enjoy it. That doesn't happen very often. Huh. So you got 1, 2, 3, 4, 5, 6. We've got 8 more things. Sam, take over. What other pieces can we find with a hyperbola? Foci. Now, once you start looking for pieces, I would suggest you do something first. What would you recommend?
Graph.
Definitely graph this thing. As soon as you start finding pieces that you need to start counting, definitely graph the thing. Where do you start graphing?
Center.
Where? Yeah.
2,
2, 1. Good. So put a dot here. Everybody look up here. Label every single number you use. Trust me, you will thank me. Even if you have to run them over with asymptotes or something, that's totally fine. Where do you go from there? Josh, take over.
Oh, you can do the horizontal radius.
Yeah, what's the horizontal?
Oh, it's
3. So you go 3 to the right, 3 to the left. And again, mark where you are. I'm gonna move this over here. So put a dot here, put a dot here. Label those numbers. Trust me. Again, you will thank me. When we start analyzing this thing, you will love the fact that those numbers are there. Keep going. Will. We got the horizontal radius. Vertical, what is that in this case? 4. So how high do we go?
5. Well,
Yeah, up to
you're
5.
going four, so
Correct.
it's 5, yeah.
And then where's the other height?
-3.
Yeah, -3. 1, 2, 3, 4. So -3. Dot. Now don't draw an ellipse because it's not an ellipse. What do you draw next? Austin.
I'm gonna draw the guide box.
The guide box. In other words, it's a rectangle with the top on the top dot, the right hand side on the right dot, the lower part on the lower dot, and the left hand side on the left dot. Draw that rectangle on its boundaries. Why is that necessary? Awesome, keep going. Why would we need a box at all? I mean, it looks nice, but, and it makes a nicer ellipse, but why for a hyperbola?
The asymptotes are connected by the corners.
Right. The asymptotes, you draw corner to corner, and it should go right through what?
Through the center.
Through the center. If your rectangle is drawn reasonably, it doesn't have to be perfect. You should be able to connect both opposite corners and go right through the center. Good. Those are the asymptotes of the shape. We're eventually going to need the slopes of those, and we're eventually going to need the equations of those. One thing at a time now. I want to graph the actual hyperbola. Question, is this hyperbola opening left, right, or up, down? Question. Up, down. How do you know? Y is the leader. If Y is the leader, this thing opens up, down, because you follow the leader. So you see this upper dot? Don't start at the center, by the way, you just get an angle. Chase the asymptotes. Just swoop over and chase the asymptote. Same thing down here. Start in the lower dot, swoop and chase the asymptote. Get closer and closer and closer without touching. And that is your hyperbola. You've actually graphed it. You're done graphing it. Once you do that, you actually have like at least a quarter or a third of your points on that test question. If it says graph and analyze, you just graphed it, which is good. One of the reasons I had to graph it, other than the fact that it wants you to, the next pieces we're trying to find with a foci. I want to know where they are. There are 2 of them, and they moved either left, right, or up, down, and I want to know which. Becca, what do you think? Do you think the foci are going to move up, down, or left, right? Up, down. Why do you say that? Right. The hyperbolas are going in that direction. The foci are what drag the function after it. Would you, by the way, would you say that the foci would be inside the box or outside the box? Outside, because that's the direction the foci are being pulled, or the graphs are being pulled. So somewhere over there, there's a focus up here and a focus down here, outside the box. In an ellipse, the foci would be inside the box, because then it would pull the graph toward it. But if you have the foci outside the box, it's going to pull the graph out and away. Does that make sense for visual? The foci are basically gravitational centers. This thing is pulling this entire graph up, and this is pulling this graph down. If it would have been a focus here and here, it would have pulled it in and around and made an ellipse. So take over, Katie. How far away from the center is the focus? 5. The focal move. So where would that be? We're at a height of 1 now. Where should this be?
5.
Up 5, which gives you a height of what?
6.
6. This is the first focus. Give me the coordinates. What comma what? 2 comma 6. It was 2 because it was already over 2 for the center. 2 comma 6 because it's up 5 spaces. Give me the other one while you're at it. We're at a height of 1.
2 comma negative 4.
2 comma negative 4. Good. Does that make sense to everybody? Equals. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got, wow.
I don't even know what this is.
Let me see, take over, Mary Clark. What other objects could we find?
The vertices.
Vertices. Tell me where they are. They're kind of sort of staring at you.
2 comma 5.
Yep, 2 comma 5. 2 comma what?
Negative 3.
Negative 3, correct. That's why, I mean, I made a mess out of this, sorry. But that's why writing the numbers ahead of time is going to save you a lot of time later. All you have to do is say, oh, this is up 5, 2 comma 5, vertex, 2 comma negative 3, vertex. Just write them down, you're done. There are 4 more parts. What 4 parts are missing? Joe. Like, what can we find next?
The slope of the asymptote.
Slopes of the asymptotes. By the way, slope is what again? Rise over run. If you wanted to get the slope of this line, you have to find 2 points and get the rise and run. May I humbly suggest, if you use the center and one of the corners, this is the rise, this is the run. What is the rise?
4.
Yeah, how do you get it? It's the what?
Vertical.
The vertical radius. Vertical means going up and down. That's height. And then the other one is what?
And the horizontal radius.
Horizontal radius. The formula for slope, vertical radius over, wow. That's like making V's. Horizontal radius. In this case, it's what over what?
4 over 3.
4 over 3. How do you get the other one?
It's the negative version.
It's the exact negative of the other one, which in this case is what?
Negative 4.
Negative 4 over 3. Did everybody catch that? The only thing in this whole mess that was vertical was the vertical radius. In that case, that's 4. So it's vertical over horizontal, rise over run. So it's going to be 4 over 3. Okay. Now, can somebody give me an equation for the first asymptote? I'll tell you right now, the slope of the first one is 4 over 3. All you need is a point, and you can do point slope form. Nate, take over. What point would be particularly nice to use for the asymptotes? There's one point that both of them go through, and it's nice. What? The center. In this case is what? 2 comma 1. Correct. When you're doing point slope form, use the center. Could you use this corner? Yeah. You have to do extra work to find it. The center you already have. What in the name of all that's holy? How did we do? Anyway, so go ahead and construct that for me. Point slope form. What is point slope form again?
It's
It's y minus
y minus
y1
y1
equals m parentheses.
x minus x1.
Good. Go ahead and do it.
So
So y minus what? Just use that.
so we get 1.
1 equals, and what slope would you use?
4 over 3.
4 over 3. That's your new slope. And then parentheses,
X minus 2.
x minus 2. You just found the first asymptote. Can somebody give me the second, Blaze, give me the second asymptote. There's only one tiny change.
Y minus 1 equals negative 4 over 3,
Negative 4 over 3, parentheses.
x minus 2.
Right. Use the exact same point. They both go through the center. You are done analyzing this thing. And you're done with problem number 3. Questions? Okay. Your assignment is not the whole thing. I would like you to do 1, 2, 3, and 4. A couple warnings. Number 2, there's a missing denominator. What is it? Okay. It's 1. Yeah. It's gonna be y minus 3 parentheses squared over 1. Number 1, you should be able to get on your own. By the way, the fact that those two radii are the same, don't let that throw you. Is it a circle? Normally it would be if it were, why is it not a circle? It's subtraction. It's a circle turned inside out. Just remember, just like an ellipse, you can turn inside out, left, right, or up, down. Same thing you can do with a circle. You can turn it out, inside out, left, right. I wish I had thought of that earlier. Or up, down. Does that make sense? And whatever's the leader is whichever direction it's going to open. Rest of the hour is yours. We go ahead and pound away at those. I will check off 1, 2, 3, and 4 tomorrow. And then 5, 6, 7, we'll get extra notes on that. Tomorrow is Thursday. How many people are going to be gone Friday? Okay, how many people are gone tomorrow? Check YouTube. I'll be posting this tomorrow. I'll be posting tomorrow's tomorrow. So, you know. Then Friday, we'll see you. Okay, rest of the hour is yours. Call me over if you get stuck, or come on over if you get stuck, whichever you prefer. Otherwise, go to it. And everybody's listening at home, here's my hand waving goodbye. Bye-bye. Let me see if I missed anything here. Here's the panoramic shot. And, nope, that's good enough. Okay, cheerio.